So the first question you need to answer is, how was the weather like that day? Go ahead and say out, think about it. Okay, discuss in your group, later on write down the answer. Secondly, where did we collect our data? Some of you collected your data before the cleansing biotope, some of you collected the data after the cleansing biotope. Remember to say that, okay? And next, when did we collect our data? Okay, last but not least, what were the data collected? That means what parameters did we collect? How did we collect our data? Right, so what I want you to do now is, in every group, you have this worksheet. Alright, it's a group worksheet. I want you to fill in section A of the worksheet. What were the data collected? What did we measure? Give me the four indicators. Temperature next. Dissolved oxygen next. pH next. Turbidity. So for today, right, we're going to analyze data from these four indicators. Okay, I'm going to assign each group to target and investigate on just one parameter. So next, okay, I want you to predict, okay, the result at site A and site B, and also give reasons for your prediction. So what happens is that, okay, I'm going to get you to predict, for example, site A, who is doing temperature? This group, right? Did you did at site A or B? A. So site A, you have data, right? I want you to predict what is the temperature at site B. Understand? So you write down in your worksheet, okay, site A, what is the temperature you recorded, and then you predict for site B. Alright? Now, turbidity, who is doing turbidity? Very good. You are at site A or B that day? B, right? So you write down the data for B and you predict for A. Always remember to write the unit. Do not leave it blank. Okay? When you have the value, make sure you write the unit as well. Clear? Alright, I give you just 3 minutes to do it. Carry on. Okay, when the pH is low, what does it mean? The water is what? Clean or what? No, use the, it's not clean. May not be polluted. When pH is lower than 7, what do you say water is? Acidic, yes. So after 7 is? Alkaline, that's all. But if it's too acidic, then we have a problem, right? Or it's too alkaline, is the problem. So now it's time to predict A and B. Do you think there will be any change in the pH? If yes, why? If no, why? Just a prediction, no worries. Okay. Now, who is doing turbidity? Okay. You are site A or B? B. Okay, so what was your value?
40 JTU.
40 JTU. Okay, so what do you predict site A to be? 60 JTU. Reasoning?
Because the water before cleansing biotope should be more dirtier than the water after the cleansing biotope.
Why do you think that the water is less turbid over at site B?
Because the cleansing biotope.
What does the cleansing biotope do?
It helps take out the excess.
Purify, are you sure purify? Filter the water. Alright, so sediments may be trapped. Okay? So today's lesson, right, I'm going to teach you how to analyze the data. Right? Now, so how do you analyze any data? Step 1. Okay, before you make any reasoning, you just describe your observation. Just tell me what you see first. Okay, what do you see? What do you observe? Usually for a graph, right, or chart, right, you will observe things like, what is the highest value? What is the lowest value? Does the value change over samples? Or does the value stays the same? What you need to do next is that suggest reasons for your observation. Let's say you feel that, hey, I see that site A and B, there's a difference in my parameter. I want you to give reasons why. But make sure you back up your assumption with certain evidence that you may have collected from the fieldwork. Alright? And there's also a map here to help you in making your conclusion about why is there a difference between site A and B, or why there isn't a difference between site A and B. Now, let's talk about temperature. Okay, which group is doing temperature? Okay, so temperature, tell me what do you observe?
Temperature of B is higher than temperature inside B. Because group 1 has the lowest temperature inside B.
Okay, so you're saying that site B has a higher temperature as compared to site A. That's number 1, first observation. Secondly, Lane 1 Lincoln group 1 has a lower temperature as compared to the rest of the 3. Okay, let's explain one by one. They may see what wrongly?
The scale, or maybe they didn't measure properly.
How do you measure the temperature that day? There was a temperature strip, right? Is it possible that the strip can spoil?
Yes.
Possibly, right? Okay. What else? Why is your second observation, side B is higher temperature than side A?
We realized that side B, the exposed surface area is bigger than side B.
So you are saying that side B, the exposed surface area is bigger than side A. So
So it gives more heat.
So there's more surface area to gain more heat. Therefore, you feel that that's the reason why side B has higher temperature than side A. Is it possible? Does it sound logical?
Yes. Yeah.
Possibly. Let's take a look at this photograph. This is side what? A, side A, right? So what do you think, other than the surface area, okay, so there's a small surface area for the heating. Other than surface area, what else do you think would have affected the temperature at this location?
The shapes of the tree.
The vegetation that provides shade, right, could have lowered the temperature. Alright, compared to side B.
Just open.
It's more exposed, right? So what will happen to the temperature?
It will rise.
It may increase, right? Okay. Now, so these are evidence. That's why I tell you to take photographs and sketch, so that you can later on give your reasoning, and then this can be evidence to support your conclusion. Alright. However, that is why it's so important for you to always annotate. When you annotate, right, this can provide evidence for people to see, okay, why you make that certain, why you make certain reasoning. For example, just now you say that vegetation, right, provides shades, right? So we annotate, right, you write vegetation which provides shade and possibly lowering the water temperature. Now you see why is it so important to sketch and annotate now. Now next, pH. Which group is doing pH? Share with us.
The graph of 1 Newton and 1 London hour is the same except for the YSI.
Okay, you're saying that all this data is different from YSI. That's the first thing you see. So you're saying that the rest of the examples, they are the same, especially between side A and B. So side B, there's no difference in pH, right? And then YSI is different. Now, tell me why. Tell me why you feel that YSI is lower.
So because the one took the data from the side.
So you are saying that because YSI probe is further away from side B, right? So there may be a change in pH. What other possible reason? The rest?
There are also a drainage of
There's a drainage over there near to YSI, so you feel that it may have influenced the pH. What about the rest of you? Why do you think YSI has a different reading as compared to... They took a different water from different places, which is also their point. What else? Okay, what is the data for side A and B? What is the pH? 8. Why is that? What is YSI? Around 7.8, right? I'm going to ask you, remember that day when we did the pH testing, we used the pills? Is it possible for us to measure 7.8?
Yes.
No. Not really. Yeah. Okay. With the pills are.
Yes, with the pills, with our kit. Can we test 7.8?
Not the FU.
What? So what do we have?
You need have
7.
7, 8, 9, 10.
Correct. So if you recap, right, when we use the water testing kit, our pH, our testing kit can only test at whole number. So 4, 5, 6, 7, 8, 9, 10. Can you test anything that's in between? No. So which one is more accurate, YSI or our water testing kit? Now next question, why is side A and B the same for pH? Why? From the map, is there any clue? Look at the lines. Look at your map. The lines, blue color is where the water is flowing, and then there's a brown color dotted line that tells you the water is going back somewhere.
Because the water comes back, so when it hits other water, it is the same.
Okay, what is the same?
The water.
The water is the same, so everything should be the same. Next, dissolved oxygen. Tell me what do you observe first?
We can observe that the glucose rising power as a level dissolved oxygen of 0 parts per million compared to the rest of the groups which have 4 parts per million.
Okay, so you are saying that when you are testing the water quality for dissolved oxygen, they didn't do it properly. Such as, what they didn't do properly, possibly? Maybe they didn't shake properly. What else? The amount of dissolved oxygen tablets that we put in, how many are supposed to put in? 2, right? They may put in only 1. What else? What do you mean? They may have not tightened it. What else? The tablets may have been contaminated. What else? There may be air bubbles. What else? Good. Remember when you collected water, I pour inside a container and say, cap it straight away. They may not close it properly. May not have cap it. You know when you don't cap it, this oxygen can escape, right? So when they put it on the floor, then they uncap it, then they do other pH, do their temperature. They may not have kept it back. So this may affect the accuracy of the dissolved oxygen data. You see, that's why it's so important, right? When you go out in the field, right, there's certain things like when you do it, right, you have to do it very accurately. If you miss one step or you are very careless in certain steps, your reading may be different. That is why I got 4 groups to carry out sampling at site A for all parameters. If I only depended on the data, will it be accurate or not? No. So I need more than 1 sample, just in case. And then in this case, I see that this one Lincoln group 1, one Lincoln group 2, and one Howard group 2 is at 4 ppm. I can say that reliably, our data collection that day, the result was 4 ppm. So now you see the importance of having more than 3 samples at one site. So every time, remember this, from Sec 1, Sec 2, Sec 3, Sec 4, you're going to do GI. And every time you are doing GI, right, you must take more than 3 readings, preferably more, so that your data is reliable. You cannot just depend on one person's data. Do you think dissolved oxygen changes with time?
Yes.
Yes.
How will it change?
Because in the afternoon there is heat, there's more heat there at night.
Is it heat or does it so?
The temperature will be higher than dissolved oxygen will increase.
So he's saying that, he's saying that in the daytime, there's more heat. So the temperature is higher. So the dissolved oxygen will be lower during the daytime. Especially during what time? Maybe can you give a guess?
1 to 3.
Like 1 to 3 o'clock, the dissolved oxygen level should be lower. Anyone thinks otherwise?
In the daytime, the plant
During the daytime, sorry.
photosynthesis,
Okay.
Photosynthesis, there's more dissolved oxygen released, and nighttime is colder than death and the sunlight, and plants respire, then they take in oxygen.
Okay. Do you think anything that will affect the turbidity?
So when you raise them, some chemicals around in the air that explode, then of this will throw it down to that.
Turbidity? Turbidity is about chemical or sediments? Sediments. Kai?
You'll collect some dust in the air, and then maybe when they reach the ground, then the ground got soil and everything, they will wash it.
Okay, when you went to the area, do you see soil?
Yes.
Yeah.
Look at the map. Is there anything that can affect the turbidity?
Yes.
Rocks, pebbles, what else? There's this huge area that may affect. Drain, yes, there's a lot of drains. Construction site. So when there's a rain event, what will happen?
Surface runoff.
There may be surface runoff. Surface runoff is water.
Yeah, muddy water.
So there may be muddy water. So there may be what? Soil sediments being washed towards the water. So it may increase the turbidity. So now I'm going to show you turbidity over days. Again, this data you can take from NIE SLL website. This is the turbidity chart from 16 March to 24th March. Can you see that there's a spike here? So like what you said, it could have rained to this day, right? And yes, it actually rained on 19th of March, which brings a lot of sediments into the geoeco water and then increases turbidity. Okay, write down the data and I want you to write down the analysis. What do you observe? Again, same thing. Step 1, you tell me what do you observe. What is step 2? Step 1, you tell me what you observe. What is step 2? You provide reasons why. Step 3, what do you do? Support your conclusion with evidence.